Hello guys, my name is Akibale Stephen Bugada and welcome to the Senior High School Mathematics Forum. I bring to you differentiation of trigonometric functions. So we last talked about how to use the first principles equation to differentiate trig functions. So now we are going to look at how to differentiate trig functions without using the first principle. And note that all the rules of differentiation are applicable here. And then to the last video, that is on the implicit functions, I didn't talk about one thing. That is, you can also differentiate um, an implicit function to the given number of differentials they want. That is, they can say find the third derivative of a particular implicit function, and you have to do so. So those who watch this video alone will get to know that they can ask you that one too as well. Or if they also see somewhere without watching this video, then thanks to their God. So now, let's quickly deal with differentiation of these three functions. I don't always want the video to be long in such a way that it will be boring. That is why I always bring a few questions on board and then to make them understandable, comprehensive to you so that when you grasp the concept, you can apply that concept and solve more and more on your leisure time. So now as we move on, um, I'll solve questions with you, but our first we will have to remember of something. So that is from the first principle, we realize that when you differentiate the cos x, when you differentiate cos x, what will you get from the first principle? When we did so, we had negative sine x. So let's quickly remind ourselves of that. And also, when you differentiate sine x, what will you get? So the last time we used the first principles equation, we had what? Cos x. Good. We need these two basic differentials in order to deal with others. Though we use the first principle for tan, and I was telling you that you should go and use same first principle for cot and others. I hope you did them, but don't worry. Still, we can use differentiation to do them here. Now, let's quickly move on to today's tuition. So now that we know that the differential of course is equal with respect to x is equals to minus sine x, and the differential of sine x with respect to x is equals to cos x, then we move on to solve these particular questions that will make you grasp the concept very well and keep it in your head that all rules of differentiation are applicable to these functions as well. That is the chain rule, the product rule, and all sort of rules. That is same way it is applicable to the implicit functions, or same way they are applicable to the implicit functions that I didn't talk about. So now let's move on. So right now I have some questions here. That is questions. I have some questions here. What do they say? The preamble is not there, but let me give it off head. The preamble says that differentiate the following functions with respect to x. That is, you are finding the first differential alone. From there, we'll come and look at higher derivatives of some of that cos and sine, and that will be all. We'll move on. So now, let's move on. Let's differentiate this particular function. In order not to make the time beat us, we have to limit the video within 30 to 40 minutes. So let's move on. But you understand it. You would understand the concept, believe me. So now that they are saying we should differentiate cos of x plus 2. But we know that differential of cos x is equals to minus sine x. So what will you do? This one is not the same, though if you even get the same answers, but this will not be the same as this because this particular function, I don't want to go there because you haven't done algebra of those functions and those things. This particular function has been shifted to or towards, I hope you've done shifting, has been shifted to either the left or the right. So it's has been shifted to um the left by 2 units. Have you seen that? So that's what we say, that using this one, saying this one is a parent one, this one has been shifted by 2 units. Have you seen that on the horizontal axis? So now let's move on. Let's differentiate this one, because you don't know what I am even talking about. When you happen to go to colleges or when you happen to do mathematics, you will know that. So moving on, we will have f of x to be equals to cos of bracket open x plus 2. Simply as this, guys. So now, how do we differentiate this? But we know the differential of this is this. So we quickly say that we are using chain rule here like that. Let v of x to be equal to what? X plus 2. Have you seen that, guys? So now we'll say, substituting this one as x plus 2, we have f of v of x is equal to cos of what? Cos of what? V of what? X. Have you seen that? So this one has become the same as this. That is v of x representing x. Have you seen that, guys? So now we are differentiating this one with respect to v of x. So in differentiating with respect to v of x, we'll have f prime of v of x. Have you seen that? It's equal to, what will you get? You will get minus sine. Have you seen that? Minus sine of what? V of x. Have you seen that, guys? So this as simply as this. Then, but they said we should find f prime of x and not f prime of v of x. So what will we do now, guys? V prime of x will be equals to, we are differentiating this one as well. So will be equals to 1. Have you seen that, guys? Now using our chain rule, which says that f prime of x should be equals to f prime of v of what? X. Have you seen that multiplying by v prime of x? What will we get now? We will now have it to be minus sine of what? V of x, then multiplying by 1. This will be equals to substituting v of x as x plus 2 into the expression. We will have the f prime of x to be equals to minus sine of what? X plus 2. So this is our final answer. I hope you've joined me on my differentiation using you've joined me on rules of differentiation, so you wouldn't have problems on this. So let's move on, guys. Let's move on. Let's move on. Again, we have tan x here, of which we differentiated earlier on, but we will have to differentiate it here again. So what will we do, guys? Now, that one too is easy to deal with. We will have it as g of x is equal to tan x. From your knowledge based on trig, we can because we are using these two basic differentials to do everything. So your knowledge based on trig will tell you that tan x is equals to sine x all over what? Cos x. Have you seen that, guys? So now let's differentiate g of x. Someone will say that, but chairman or tutor, We know the differential of cos x and we know the differential of sine x. Why don't we substitute them into this function and say that is the differential of g of x? You are funny when you say so, because it won't be that way. It will not actually be that way, and it isn't even that way. Now, what we'll do is that we say v of x is equal to sine x. Have you seen that, guys? U of x is equals to cos x. And then this is a function, this is a function. A function over a function is a rational. That is a rational function. So what will we do now, guys? And then this shouldn't be zero, as you know already about rational functions. So what we will do now, guys, is that when we have a rational function, when we have a rational function, when we have a rational function, we always use the quotient rule to differentiate it. So in using the quotient rule, we'll have it as g prime of x to be equals to v, this v of x over u of x. So we'll have it as u of x multiplying by v prime of x, that one minus u prime of x multiplying by v of x, that all over u of x, that function squared. And this is the quotient rule. This is the quotient rule. I guess you've not forgotten about it. So now we'll have it as g prime of x being equal to, now we have u of x to be what? U of x is cos x. So we quickly substitute cos x here, multiplying by what? V prime of x. And v of x is sine x. When we differentiate sine x, what will we get? We'll get cos x. So cos x multiplying by cos x, then minus, we have u prime of x. U of x is what? Minus u prime of x. But u of x is what? U of x is cos x. And when we differentiate cos x, we'll get minus sine x. Have you seen that, guys? So when we substitute that one here into bracket, minus sine x, then multiplying by v of x, which is sine x, as you can see it here. So sine x. Then this is all over. This will be all over. This will be all over u of x squared, which is cos x squared. So we'll have cos x, that one squared. Have you seen that, guys? So now this one will be equal to minus minus, you have plus, you have cos square x, then minus, that's plus sine square x all over cos square x. Have you seen that, guys? Who is a genius at this moment? Someone can decide to divide and get the identity at that instant. Someone can also decide to substitute a particular identity and get that identity finally at that instant. So in any of the ways, you will still get the identity we are talking about. Now, can you see the identities we are talking about? When you divide cos square x by cos square x, you get 1 plus sin square x over cos square x, you get tan square x. So 1 plus tan square x is equals to what? Sec square x. Or you can simply cos square x plus sin square x is equals to 1. So 1 over cos square x will give us sec square x. So that means that our answer is equals to sec square x. And that is our answer. When you differentiate tan x, you get sec square x. And then when we did so using the first differential equation, we had sec square x. So the answers are not varying. You can choose either ways. But in terms of in case of examination, this thing, limitations, you have to know, because of examination limitations, you have to learn both of them. They can say use the first principle equation only. That's where you will be suffering. Meanwhile, you know the alternative. So let's move on, guys. There is another one here. So we've solved the 2. Now let's go to the 3, which says that P of x is equals to 3 sine square 4x. So how do we solve this one? But we know our basics differentials already from our first principles. That cos x when differentiated will give us minus sine x. Sine x when differentiated will give us cos x. So let's move on to solve the other one too. That is, we have it as P of x. P of x is equal to 3 sine square 4x. And guys, you don't need to forget those rules of differentiation, because you can't just go straight to differentiate this one like that, because it is not in the form of sine x or cos x, whereby you know the differentials already and then you just have to put them down. No, you don't have to do so, or you can't even do so. So now what you need to do is that you let v of x be equals to 4x. So when you substitute v of x into this, when you replace this by v of x, you realize that it will be like a function of another function. That is a composition of a function. P of v of x, that is the composition of these two functions, will be equals to 3 sine square what? V of what? X. Have you seen that, guys? But still, this one cannot be differentiated. So what do? We further on analyze it and then come out with another one to see whether it can be differentiated or not. So now, let's have something like this. Let's put it in this way. P of v of x should be equals to 3 into bracket sine of what? V of x. Have you seen that, guys? Now, are you thinking of what I'm thinking now? Are you thinking of what I'm thinking now? I guess you are thinking of what I'm thinking now. So that means that we can further put it into a particular function. That is, we can say that let u of x to be equals to what? Sine of what? V of x. Have you seen that, guys? We can say let u of x be equals to sine of v of x. That means that sine of v of x can be replaced here. And then we'll have it in this way. P of u of x. Have you seen that, guys? P of u of x. Sorry, P of u of x. It will rather be this way, guys. Let's say the function, we are replacing it with another one. Let's say g of x is equals to 3x squared. Have you seen that? And this u of x is inside that one. So what do? We will now have it as g of u of x to be equals to this one. Have you seen that? So we can replace this as g of u of x. Have you seen that, guys? So now, straightforward, we use differentiation. That is the chain rule to differentiate all this. So now what we will do is that we will have p prime of x to be equals to g prime of u of x, because we have divided. Let me write them clearly here. We have g of x to be equals to 3 u of v of x. Have you seen that, guys? This will be how it will be written, or this is how it will be written. And then we'll have u of v of x to be equals to u of v of x. So u of v of x rather to be equal to sine of what? So this one would have been this squared, sorry. So this one is equals to, let's just give this a variable. So this one will be equals to sine of v of x. Have you seen that, guys? And then we will now have v of x to be equal to 4x. So guys, p prime of x is equals to g prime of u of v of x. Have you seen that, guys? Then that one multiplying by u prime of v of x. With your knowledge on the rules of differentiation, you can follow me. Then we have v prime of x. So that is the chain rule. So moving on, we'll have differentiating this one, the v prime of x will be equal to 4. Have you seen that, guys? And then u prime of v of x, that is, you are differentiating it with respect to u of x. We will get it as, when you are differentiating sine, you get what? Cos. So we have it to be cos of what? V of what? X. Simply as that. Then we'll differentiate the final one, g prime of u of v of x. Have you seen that, guys? With respect to u of v of x, which will be equal to 6 into bracket u of v of x. Have you seen that, guys? So simply as this. Then we will now bring all together here. So we'll have p prime of x to be equal to 6 u bracket open v 6 u of v of x rather, and multiplying by cos of what? V of x multiplying by 4. So this 4 will multiply by this, giving us 24 cos v of x. Have you seen that, guys? Then multiplying by u of v of x. So what is u of v of x? U of v of x is sine v of x. So we will now have it as 24 cos v of x multiplying by sine v of x. That is replacing the u of v of x, because here is it. Have you seen that, guys? I think you are confused, but like, go to the differential distinct one, you will get to know about it. So this will be how, like this, how it will be. Then you substitute v of x into it. You have 24 cos of v of x was what? 4x. So 4x sine of 4x. And that one too has been differentiated, guys, like that. So let's move on to the last question. And the last question says what? That we should differentiate h of what? X is equals to cot 2x. So in differentiating h of x is equals to cot 2x, using our knowledge and trick, we can simply express this one as 1 over what? Tan 1 over tan what? 2x. So guys, have you seen that? We'll have it as 1 over tan 2x. Now we can use the quotient rule here. That is, let u of x be equals to 1. That's one function like that. And v of x be equals to tan 2x. Have you seen that, guys? But this tan 2x as well can be differentiated using the chain rule. How do we differentiate this one using the chain rule? When we are differentiating that one using the chain rule, we say, let's bring that one here and differentiate that one first. So we say v of x is equals to tan 2x. So we say p of x should be equals to that 2x. Have you seen that, guys? So we'll now have it in the form, we will now have another one like in this form. v p of x is equals to v of p of x rather is equal to tan p of x. Have you seen that, guys? But v prime of x will be equals to what? V prime of what? P of x multiplying by multiplying by um multiplying by p prime of x. Have you seen that, guys? But here we know that p prime of x will be 2 and v prime of x will be equals to what? We differentiated and we had sec square for a tan function. So we'll have sec square p of x. Can you remember in the first question we differentiated, or that was the third question, the second rather, and we have sec square, we had sec square x. So that can be replaced, that can be used here. So now we'll have it as sec square p of what? X here multiplying by 2. But p of x is what? P of x is 2x. So we'll have it as 2 multiplying by what? Sec 2 multiplying by sec square 2x. So that is the differential for tan 2x. That is the differential for tan 2x. But we were asked to differentiate cot 2x and not tan 2x. So we expressed it in this form. And we said let u of x be this, v of x be this. The reason why we are doing all sort of differential of this tan 2x is that we will need it. So now u of x over v of x is a rational. That is, it is a quotient of two functions. So what will we do now is that we will use the quotient rule. So we'll have it as h prime of x will be equals to v of x, that's using the quotient rule, multiplying by u prime of x, then minus v prime of x multiplying by u of x. Guys, have you seen that? All over v of x, that one squared. So guys, this is what we will get. Now u of x is 1, meaning u prime of x will be what? Equals to 0. Differential of a constant is 0. And I explained to you in my earlier videos. So h prime of x will be equals to v of x. Where is v of x? V of x is tan 2x. So we'll have tan 2x. Have you seen that, guys? Multiplying by u prime of x, which is 0. Have you seen that, guys? Then minus v prime of x, which we differentiated up to this level. And we had it to be 2 sec square 2x. So that will be 2 sec square 2x multiplying by u of x, which is 1. Then all over v of x squared, which we represented as tan 2x. So that will be tan 2x, that one squared. So guys, we can move on. So now, moving on, we will have it to be equals to 0 times this. We will still have it to be 0. Then we'll have 2 here. Then we'll have sec square 2x. Have you seen that, guys? Then we'll have sec square 2x. And we'll have plus, so times 1. So it will still be the same. Now we'll have it all over tan square 2x. Have you seen that, guys? Tan square 2x. So it is all over tan square 2x. So guys, have you seen how it goes? We have squared this one like that. So in moving forward, we'll have it to be minus 2. Then we'll have sec square 2x all over this tan. 1 over tan square 2x will be what? 1. When you have 1 over tan square 2x, what will you get? 1 over tan is what? Cot. Have you realized that? So we'll have it as cot square 2x. Cot square 2x. Have you seen that, guys? So we'll have it as cot square 2x. So this can be written as this can be written as this can be written as equal to minus 2 sec square 2x, then cot square 2x. Have you seen that, guys? So this is the differential. This is the differential. Have you seen that? This is the differential. So that is really the differential. So thank you for watching this video. See you in the next video. See you in the next video. Yeah. Subscribe, like, and comment. Share as well. Thank you.